Hey, I'm back. So I wanted to go over in this video briefly what some things to look out for, where common pitfalls happen, and just things to be very aware of. Um, in mathematics, there are assumptions that are usually made, um, and when you get into further mathematics courses, if you don't have a real strict background in your or if you're not fully grounded in mathematics, and for instance, elementary algebra, etc., things like that can really screw you up because you can overlook very simple things, or the simplicity of certain equations that may cause you a lot of time, effort, or even points. For instance, on an exam, that you probably be slapping yourself in the head for for not realizing. That's happened to me. That's why, plenty of times. So one thing I want to mention is this. For instance, a to the 0 equals to 1, meaning that a, this is the first one, the big one, that I notice a lot of students seem to forget, mess up on, and they usually screw this one up. A to the 0 is a constant, meaning that it could be any value, right? I can have negative 1 to the 0 equals to 1, or 10 to the 0. It's any real number equals to 1. So a is any real number, right? Now that goes to say that if I have 5 to the negative 1 plus 5 to the 1, right? By rule of exponents, anything with the same base allows us to add the exponents, right? So that's going to be negative 1 plus 1, right? Equals to 5 to the 0 equals to 1. And you know, instructors sometimes like to throw these little tidbits in there, and to get you this resultant 0 right here. And just to know that it's 1, it saves you a lot of hassle, and especially, again, for instance, calculus, you're going to use this concept a lot, where it might, and when it comes to logarithmic scales and dealing with natural log and exponents, oh yeah, it really gets in depth. Anyways, another thing is 0 divided by a being any real number, right, besides 0. So a not equal to 0, right, equals to 0. So this expression right there equals to 0 if a is any real number not equal to 0. What does that mean? Well, again, we can have 0 divided by any number. You pick it. 0. 0 divided by 3 equals to 0. Any integer, right? But we cannot have 0. 0 divided by 0 is undefined. And usually you have to go through a detour, I guess you could say, and kind of troubleshoot whatever expression gave you 0 over 0 in order for you not to in order to yield anything other than 0 over 0. What am I saying right there? Well, I mean, that's for that's a little bit more advanced to talk about, especially when it comes to calculus. This happens a lot when you're finding limits. And to avoid this, you usually find common factors, and reduce the expression to something a little bit more manageable, where it's not going to yield this 0 over 0. But just know for now that 0 over any any constant. Excuse me, I just got done eating a pollo loco. So 0 over any real number besides 0 is 0, right? And a is a constant. A is always denoted as a constant, or any value like that. And then we show some examples here, and then 0 over 0 is undefined. Now, I can't think of anything else that I like to expand on. These are the specifics dealing with the course that I kind of volunteer and help with at the Midnight Mission, and I'd like for you guys to acknowledge this, because, well, here, let me see. say if we were going to get an example like this, 5x squared. So we're now throwing in some variables, right? Right? Rule of exponents say that this, because this we're dividing, anything with the same base. Now this is a base. Anything with the same base allows us to just have an subtract or add the exponents, right? So here are exponents. So because x and x are the same base, we can simply, because we're dividing, we can simply just subtract these two exponents from each other. So we can write, and then we can see that these reduce. So the factors of 10 are 2 and 5, right? And this is 5. This reduces to 1. We're left with 1/2 times, and then I'm going to rewrite this. Because it's the same base, we can write it like this. Right? Just a different perspective on this. And then we can continue and write the next one over, right? Y times y to the -6th, right? Okay, so we're stuck with 1/2. Can't do anything with that. That one has no significance here. Okay, but rule of exponents now say that because we're multiplying these two components, or these two elements right here, with the same base, they have the same base, but since we're multiplying, we can add the exponents. So 2 plus -2, right? Remember the additive inverse, right? Times y 3, we're going to add these exponents, -6, right? And then let's see how much time I have. Good, I have plenty of time. Plenty amount of time. I'm going to erase this. And I'll go over in another video the rule of exponents, right? So just bear with me. So we're stuck with 1/2. Again, multiplication. When talking about multiplication, when dealing with rule of exponents, right? Or within the rule of exponents, multiplication allows us to add the exponents when they have the same base, right? So we're adding this. So 2 minus, that's 0, so x to the 0, times y, and 3 minus 6 is -3, right? And then 1/2, and then as we stated, x to the 0 is 1, right? Because anything to the 0 is 1, right? And y to the -3, and then this could be written as 1/2 1 over y, or 1 over 2y. Make sense? I'll get into further detail of why we brought. Let me finish something. This is 1 over 2y cubed. Sorry about that. Why we brought the y cubed below. That's really called the I can't even say it. Multiplicative inverse, I believe it's called. But I'll get into further detail about that. But for now, just understand these little pitfalls. A to the 0 equals to 1, and that's what we got here. X to the 0 is 1, right? And that's the reason why they cancel out, because they resolve into 1, right? And then 0 over any constant is besides 0 is going to be 0, right? So 0 over a not equal to 0 equals to 0, right? And then just a brief, I guess you could say, overview on rules of exponents here and how you can see them in different perspectives. Hopefully that helped. I gotta kind of end this video because again I only have 10-minute restrictions. So I'll continue with this stuff in later terms. Thanks.